Okay, I just want to test some sound settings, but good evening, everybody, if you're watching. TAs, if you are available, could you please let me know through chat? Okay, great. So if you're watching and you have questions, what we're going to do is please look on Learning Suite, so you should be able to see. So on Learning Suite, in the Content area, under Contact Information, you can see the different TAs, and I believe you can send messages to Cameron K., Jameson, and I believe Sam and Josh are available as well. So if you have questions anytime, just email them and then they can communicate with me via the stream. Okay. Additionally, what I will be using during the stream is, if you go to the schedule, I have uploaded a set of slides underneath the midterm date. That will just be a set of slides that I'm going through, and then we'll do some practical things as well. So again, thank you for being here, and let me know if you have questions as we go along. So I think what we'll do is I'll discuss, what's kind of you should expect on the exam, and then we can pause for a minute and kind of answer questions. So how does that sound? All right. So as you know, there's two portions to the exam. So one you'll be taking in the testing center, and that opens up on tomorrow and closes on Friday. This will be a collection of conceptual problem solving as well as an ERD. So you'll need to know how to do one of those once again, and we can do an example of that here. And then there's also the in-class, which is what we'll be doing tomorrow, so which consists of access queries, pivot tables, and solver problems, and we can look at some of those as well. Okay. So going back quite a ways, we discussed at the beginning of class, we talked about paradigms and paradigm shifts, and so I just kind of want you to think about what we discussed in terms of, the Christopher Columbus picture here. We said that paradigms they establish the boundaries that we have, as well as set the rules that we need while we're interacting in the world. So I like the Christopher Columbus example because it sets up those two things that paradigms have nicely. Here we have a picture of Steve Jobs with the tablet and the covered wagon. So we discussed that so paradigm pioneers are people who sort of enact the paradigm shifts, and they're often on the fringe of, they're not in mainstream companies, typically. And then we talked a little bit about Blockbuster and sort of video streaming that was going to be happening, Netflix, all those companies. And Blockbuster essentially experienced what we call paradigm paralysis, in the sense that they couldn't adapt to the new paradigm that was being presented. And so, just as a reminder, when a paradigm shift occurs and we have a new paradigm, everybody's put on the same playing field again. So we go back to zero, essentially. And then we also have this concept of the two bugs fighting of digital Darwinism. So the idea that survival of the fittest, the best paradigm at the time that will be the one that prevails, and those who can't adapt to it will fall by the wayside. Okay. So as we go, if you have questions about that, just let me know, and I'll keep my eye out. But I think that's pretty straightforward. So just we haven't talked about this in a long time, so I wanted to bring that up again. Okay. We also talked about, so this is again going way back, what makes a data set, a database, tables in a relational database, you know, the good attributes and some of the problems that can occur when you're dealing with data that's set up like this. So we use this example, and we can see already, I think we pointed out that you know, we appear to have values missing here, so this is an issue of completeness. We've got different ways of coding the fax and phone numbers, so we have an issue of consistency. We have two, so we've got a Bartholomew and a Bart. So it looks like we have a uniqueness issue, because if you look, you can see their email's the same, and which indicates that they're probably the same person. So we're trying to store the same record twice, and we shouldn't be doing that. Accuracy, so if we look at you know, the street here, we can tell that they all live in the same place, probably the same last name. The street is not accurate here. And then timeliness, we don't see this in this table, but essentially just want to make sure that we have the right data at the right time. You can kind of think of the target example that I used in terms of the, you know, the person who's interacting with the system needs to know what's most up to date in order to make the correct decisions based on that data. Okay. So with things like this, it should be fairly obvious when you're reading the question exactly which type of data characteristic you're looking for. There shouldn't be any ambiguity there, but if you just want to take a little time to kind of go over each of them and make sure you understand when they occur, in what case. Okay. We also briefly touched on the difference between transactional and analytical information. So transactional information being the data that occurs that you receive or you send during a transaction. So usually things that are just basic information used in a business process that is required to support performing operational tasks. So for example, you know, the date and time, location, amount, customer account of an ATM transaction. These are just things that are involved when the system is running, just pieces of data. As opposed to, and I don't have the slide here, but as opposed to analytical information, so perhaps aggregate information, taking a look at, you know, how certain stores, kind of what you're doing in your pivot tables, you know, how certain stores are doing during certain months, data that can be used at a managerial level to make, you know, strategic decisions about what's going on in the business. Okay. And then we talked about the advantages of using a database over sort of just using a spreadsheet in Excel. And I think we decided that databases were more collaborative. They're much more limitless in terms of how much data can be stored. They allow for access controls. And if you think about it, you know, in a database, you can set up database rules that, for example, if you want something put in as a date, you know, you can force that field to say, if somebody enters something that's not a date, it will kick back and say, you know, that's invalid. Whereas in Excel, we can't really do these things. And I think we kind of came to the conclusion that overall, the use of a database is going to be more advantageous than simply using a spreadsheet in Microsoft Excel. Okay. All right. Let me know if I'm going too fast. The stream is slightly delayed from where I am, so it's a few seconds later. I'm just trying to keep an eye on what's going on. I think maybe we'll finish this out and then I'll do a quick question answer before going to the practical section. Okay, so we talked a little bit at length about the difference between serializable and virtual products. So the bottom line, something that's non-serializable, it's going to be something that you don't care about that specific item. So within a group of the same similar items. So for example, food is a great example. You know, food is non-serializable. You're not going to want to know of the bunch which particular banana it is that you are selling or keeping track of. As opposed to things that are serializable, like cars with their VIN, or instruments, things like that. And one of the things that we didn't touch on, but I want to make sure that you have an understanding of, is that when items are, let me bring up an example. 1 second. Okay, so when items are serializable, we can make different assumptions about them than when they are non-serializable. So what I'm pulling up here is another version of the quiz that I made, so don't worry about, you know, I'll probably just make a new one anyway, so no one's going to be able to get answers off this. But if we look at this example, number 3, oops, let me zoom in a little bit more if I can. There we go. Okay, so Curios Limited is a specialty shop that sells expensive, high-quality memorabilia. Because the curios are so expensive, the shop encourages patrons to make purchases together, and patrons can make return purchases. So, reading the problem, you know, we're looking at which way and what type of relationship we need on both sides. So if we were to solve this just the way it's written, we break this down. So the shop encourages patrons to make purchases together. So what does that mean? Essentially that means that one product can be, and you have to look at it from that perspective. So ask yourself, for one product, how many customers can I have? So in this case, they make purchases together, so a maximum of many. Right? So we can have many customers per one product. So I'm asking myself, for each product, how many customers? Many. And then it says patrons can make return purchases. So we've got for each customer, how many products can I have? So if they can come back and make repeat purchases, then they can, of course, have many items. So a single customer can have many products, and a single product can be purchased by many customers. So we're going to go with many to many on this one. However, we can also look at it from this perspective, and this is kind of the point that I wanted to make. Let's see. If I were to take a look at this really quick. If I were to delete this last sentence, so at this point all we know is that because curios are so expensive, the shop encourages patrons to make purchases together. So multiple customers can own one product. That's fine, but we don't know the other side of the relationship. If I were to say that products are serializable, essentially what I would be saying is that a particular customer would only be able to purchase one product, so one type of product. So instead of many to many in this case, and I can go over this again if you need me to, I would actually have many to one. Okay, so because I said products are serializable, I'm getting, you know, each customer can only have the one product, so we have many to one. Now, if I were to say it was non-serializable, that changes things. So if it's non-serializable, like the fruit, fruit or food example, then a single customer can purchase multiple of those. So we go with many to many on this one. Yeah. Okay. Sorry about that. So I am recording this on my end. So okay. Yeah, so if you're missing, if you miss something, I will be posting this. I'm recording it. So don't worry about that. I apologize for the the ads. Okay, good. All right. Okay, so I'm going to leave that and come back to it if you have questions later on. But the bottom line was non-serializable, I've got many on the side of product, if products are non-serializable, and if they were serializable, then I've got one on that side of the relationship. Okay, just wanted to make a point of that. All right, so then we talked a lot about, I'm kind of skipping ahead, but we'll come back. We talked a lot about measurement and the different qualities of good measurements. So measurements should be simple, so easy to understand, both in the sense that we understand what they mean, and we understand how they're calculated. Measurements should be easily obtainable, so sometimes they can't be, you know, and that's fine. Like in the case of the census, I mean, we have to get all the data that we need, but they should be easy to collect and easy to calculate. So typically the measures will be something that we have a good understanding of. Okay, precisely definable. So we use the example of what a push-up is. So in terms of, we need to know exactly what counts as a push-up if we're going to count how many a person is doing, whether they're knee push-ups or just regular push-ups, you know, whether you have to have an arm behind your back, etc. So measurements should also be objective. So you know, we have these different dogs here, and the question was, you know, people looking at them, would they all think that they're ugly? So probably, I mean, maybe not, but the point is that if a measure is objective, different people are going to arrive at the same value when they're measuring it. Okay, validity, so important. So you need to make sure that you're measuring what you intend to measure. So this comes up a lot in psychology, you know, making sure you're actually getting at either a person's confidence. What was the example we did in class? You know, whether I said how many times they say the word is indicative of their level of confidence. It might be. It might just be because they're trying to slow their speech down so that people can listen better. So validity, making sure we measure what we intend to measure. We had the example here of the doctor trying to measure somebody's temperature with a stethoscope, which obviously won't work. Okay, and then we want to make sure that the measurements are insensitive to insignificant changes. So we use the example of, regardless of the distance, you know, of the pitcher's mound from home base or the height of it, we're still going to calculate the pitcher's stats in the same way. So also when we were discussing measurements, we had a few different calculations. We looked at percent change. So pretty straightforward. You just have to remember that when you're calculating percent change, you're going to do the last, so most recent value, I guess, minus the first value, divided by the first value. I think this part most people understand. Just remember that you're dividing by the initial or first value. And then remember, if you don't have it set to show a percentage, to multiply by 100. So quick example, I'll just do the one that we did in class. So last year I had 3.6 GPA and this year I have 3.8. What's the percent change? So this year, that's the most recent one, the last one, 3.8 minus the first one, 3.6 over 3.6 times 100. And if I run that, what's it? And just a reminder that parentheses are important. So over 3.6. Is that, you can let me know if that's incorrect or not, because I was using kind of a junky calculator. But this is how you would do the calculation. I don't want to say that's the right answer just in case it didn't pick up order of operations, but I think that it did. Okay, so last minus first over the first one. Okay, and then we've got our efficiency ratios. So it depends on what the question's asking for. If it's asking, you know, who's the most productive, we can either calculate the amount of time it takes to make one item or how many items a person can do in a particular amount of time. And we just have to make sure that our measurements are in the same unit. So 50 minutes, for example. So 50 minutes divided by 60, so that's 0.83 hours. Repeating. So the efficiency ratio here, so how many are produced over time, if I did it in hours. And I think this is, again, pretty straightforward. We do this calculation. So obviously, if we're looking at number of units, we want the person who made the most units in a certain amount of time. If we're looking at time, we want the person who took the least amount of time. But so a similar calculation that we sort of touched on but didn't exactly do in class was a defect ratio. So I just want to point out, so if we want to know, I'm going to delete this and put something else here. Okay. So defect ratio, this is, we're looking at how many, what the ratio of messed up items is to good items. So, for example, if I've got if Lucy has 4 defects, Ethel 5, and Fred 10, and we want the defect ratio, we just divide the number of defects over the number produced, like so, and then figure out who was most accurate and precise in terms of their production. So just so you don't get confused if there's time involved, when we're looking at a defect ratio, we're looking at how many bad items divided by how many good items there were. Wait, 1 second. Just want to make sure I'm speaking, because it might be the total. Oh, okay. I don't actually think it's going to be a problem on the exam, but I misspoke. I'm sorry. You want the total. So we're going to say that this is the total produced, so we're fine. Okay, so you want to take the number of defects over the total produced, not the number of bad over good. So let's see. Defects ratio equals defects over total. Okay, just to make that clear. I think I overthought that. It's very odd because I'm just in the room by myself and there's no one sort of giving me feedback, so it just feels odd. All right. Moving right along. So we recently discussed components of the computer, and we led with a discussion of the Turing machine, which I think some of you might have found boring, but was important to understand how powerful computers can actually be, that they're still kind of relegated to whatever the Turing machine can do, computer can do, and vice versa. So we talked about the most important part of the computer, the CPU, central processing unit, and then mainly we focused on different types of storage as well. We didn't really talk about I/O, input or output, or communication devices. We just talked about the CPU and then the different storage devices. So the CPU being the brains of the operation, and we watched a video with Linus where he was describing the concept of hyperthreading, and he was using eating as the analogy. So he was saying that he was kind of equating the number of mouths that you have to the number of processors, and saying that if you had more hands and were feeding the same mouth, it was really just a matter of scheduling. It wasn't a matter of adding more processors to make it even faster. So I guess the point that I'm trying to make is whether your computer's just doing multi-threading, which is just simply making it look like, and multi-threading can take place on one processor, making it look like the computer's doing multiple things at the same time when it really isn't. It's just bouncing between things really fast, is that really the main way to speed things up is to add more processing cores. So because each core can really only do one thing at a time, so if we want to get maximum speed increase, we need to add more cores. essentially. But multiple cores can be held on the same CPU. Okay. And then we looked at different types of memory. So everything that's closest to the CPU, to your outer storage. And we have this trend that things that are closer to the CPU are going to be faster, like the cache that's stored directly on there, the RAM that's part of the computer, and then finally getting onto the slower data storage. So just a matter of latency. Then we also talked about networking a little bit and described that it's important that everyone is using the same protocols. So I think I gave the example of if I wanted to write a message at the beginning at the front of the room and tear it up into small pieces, how would I effectively get it to the back of the room? And then have a person back there interpret what I was trying to say. Well, we said we'd have to number the pieces so that we would know how to reassemble it. We might even have other instructions like which language it was written in, things like that. These are the things that are going to go on the packets. So we talked about that data over the internet is sent in packets, each with a packet header, information, data, metadata about what's in it, so that, and we're following this protocol so that we can correctly interpret the data once it gets there. And the main protocol that sort of addresses how things are going to be sent over the internet is what we call a combination of TCP/IP. So I was talking briefly about the different layers of the network, and we didn't really delve into it too much because it wasn't really important for the purpose of our class, but we have TCP/IP layer involved. And so I guess I just want to emphasize that this is going to be the main protocol that dictates how things travel over the internet in packets. Okay, so we talked about the different types of media. So just a reminder, so the twisted pair being sets of copper wires that are just twisted together, coaxial cable, just with the an insulator over some copper center, and then fiber optic cable. I mentioned that Provo's lucky to have Google Fiber now. It's really, really fast because it's using light to help the data travel. Okay, and then we talked about voice over IP as well, which the bottom line was this is how we send our voice as data over the internet. So rather than using a dedicated circuit like we would over the phone, we send our voice in packets and it comes up to the other person. So it can be unreliable because you're dividing it up that way. It's not a dedicated connection, and you can't make emergency phone calls using this, but it is very cheap, and you can call all over the world using this type of technology. Okay, so what I want to do now is, and I'll probably go over 7 o'clock, that's why I'm glad I'm recording. Let me know now. I'll take questions for the next 2 or 3 minutes, so I'll just pause for a minute or two and see what happens. So again, this is just about the conceptual portion, but remember that it's not just the conceptual portion in the testing center. You'll also have the ERD, but I think that's what we'll do next, actually. You might have to space out the email address. There we go. Should be here. Try sending your email again. Okay. So I guess what I'll do now is I'll start on the ERD since I'm not seeing anything pop up. If I do, then I can always stop and do that. So before we take a look at Access, Solver, and Pivot Tables, let's take a look at ERD. Okay. Yeah. Okay. So what we've got here, this is a quiz very similar to the one that you took, but it's slightly different. So there's going to be some ERD problems similar to this on the conceptual portion, but you will actually have to draw one according to a story, as well as write out the table schema based on the ERD itself. As well as, I should also mention, in this case you will have to go from a story all the way to a schema without necessarily drawing the diagram in between. Now, that doesn't prevent you from drawing the diagram. You can draw the diagram if you'd like to, but the multiple choice will be just addressing what the table schema should look like. So let's start here. So I believe you saw the other half of this problem. So Michaela's Marble Company encourages its employees to donate blood. The company tracks hospital and donation information as shown below. Using the ERD, map the diagram to table schemas using the table mapping schema notation. So, and then there's these small crow's feet attached to the donation entity. Okay, so right away we look at it. I'll just kind of help you go through the thought process if you're a little rusty and you can't see my gesturing, so I should stop doing that. Essentially, you take a look at the cardinality of the relationship, and that will help. So if you look at the cardinality of the relationship, that helps you decide where the foreign keys are going to go. But before you even do that, right off the bat, you know that. So first you're going to need to create a table for each entity. And this applies when we have the many-to-many case and we have an intersection as well. So whenever there's an entity, regardless of what it is, we need a table for each entity. So in this case we have donation and we have hospital. So testing center portion, it's about, how many questions is it? I think it's 42 questions. Let's see, about, yeah, 40 to 45 questions. Okay. And if my sound levels aren't right, please let me know as well. I think I'm loud enough, but if I'm too loud, let me know as well. Okay, so we've got table for each entity. So donation and hospital. And then we need to, so step 2, so put primary keys and attributes in each table. So quite simply, we put our primary key in, and we make sure that we've got the PK. So the way I was telling people, if you do play the game, you'll never forget this ever again. If you don't play the game, it's just kind of a mnemonic device. There's a game called Super Smash Brothers, and there's a character, 2 characters I think, that say PK Fire. And so it's a way to force you to remember that. How do I suggest studying for the exam? Let me finish doing the ERD first, and then I will address that before we move on to the practical portion. Okay, so got our primary key, and then we add the rest of our attributes: date, amount, location, and I'm leaving it open for a reason. So hospital, we've got our primary key, hospital number, primary key, name and location, and then finally we need to ask ourselves, so look at cardinality and decide if foreign keys are necessary. Is/are necessary. Okay, So in this case, we see we've got a one-to-many relationship. So in class we talked about on the one-to-many relationship, the primary key on the one side always goes on the many side. And we sort of looked at why this makes sense. Is that right? Yeah, because essentially if you tried to store many things related to, oh okay, I'll get to that in a second too. If you try to store many things for one thing, I mean, that defeats the purpose of having the relational database. You'd have to have multiple columns corresponding to it, and it would be very messy. So bottom line, primary key from the one side is going to go on the many side as a foreign key. So I've got for donation, hospital, and it's labeled as a foreign key. And then hospital does not have a foreign key. So, I'm not sure that you will encounter this, but we talked about in a one-to-one relationship how to identify which side of the relationship the foreign key is. And essentially we said that for whichever side is scariest, that's the side that the foreign key needs to go on. So for example, up here, in the case of one-to-one relationships such as a pilot flying a small plane, which key should become the foreign key for the other entity. So the question is, which entity requires which during a flight time? So basically during a flight time, a pilot doesn't necessarily need a plane, but a plane definitely needs a pilot. So the pilot ID becomes the foreign key, and the foreign key goes on the plane side of the relationship. You can draw that out if it helps you visualize what it's about. And then on the many side, on the many-to-many case, we don't have to worry about which side it goes on because it goes directly into the intersection. Okay, so let's do, yeah, I'm definitely going to go past 7 a little bit. So let me finish this, let's do this problem, and then we will address some of the questions here. Okay, so draw the accompanying ERD. So we've got the Ben Franklin Library is interested in maintaining a system to keep track of its operations. The library is home to many different types of fiction and nonfiction books. So when patrons come to the library, they check out at least one book. Okay, so right here, you're thinking already, well, this is relationship information. So I noticed some people were getting confused by some of the introductory text in some of the problems. Essentially, what you want to look for are those relationships, because the relationships will often help you identify what the entities are, if you're not clear on what the entities are. If you're clear on what the entities are, and the relationships match, then you're in good shape. But if you're not, you can sort of look at the relationships and it'll help you decide what the entities should be. So when patrons come to the library, they check out at least one book. So I'm thinking maybe, so entities. So I've already got patron and book, okay? In addition to book and patron information, so there you go, the library also likes to maintain which books are written by which authors. So it looks like I also have author data that I'm storing. Okay, and then many textbooks are written by multiple authors, and the library carries books by prolific authors. So prolific here meaning that they've written many books. A library book can only be checked out by one patron at a time. Each library patron has a library card with a patron ID, name, and email address that the library tracks. Okay, so right here you're thinking this is our attribute information. Additionally, the library keeps track of author names and genre. Each book's title and publisher is recorded. Okay, so this last part we've got all the attributes that we need. Okay, so let me try and see if I can still maintain this up here and draw at the same time. I think what I might do is just pull this to the side and pull up PowerPoint and then try to pull it over. Okay. Okay, so we said we need patron, book, and author appear to be our entities. So let's draw those. And again, this is for your testing center portion, which is unlimited time, by the way. Okay, so I've got 3 entities. So patron, book, author. All right. So I'm just going to put a little dash underneath so we can get our attributes in. Okay, book and author. Okay, so now the easiest thing to do first is to check out those attributes before you even want to look at the relationship, which you can, but one of the simplest ways to do it is just go about looking at your attributes. I'm kind of trying to give you an algorithm for breaking down the story. So find out what your entities are, decide on the attributes, and when you're deciding on the attributes, what is the primary key? So every single entity that we have requires a primary key, and if it's not clear what the primary key is, you can and should make your own. However, if it's clear what it is, like if it says, instrument has a serial number, for example, patron ID, things that are IDs, these are going to be primary keys. But if it's not clear, we need to make our own. Okay, so each library patron has a library card with, so patron ID, I'm just going to call it PID, a name, and here, so patron ID, got my PK, I don't want to forget that, or you can underline it. I'm just going to use PK, and then name and email. Name and email, yep, okay. And then it says each, yeah, additionally, the library keeps track of author names and genre. So we can kind of assume that author names could be the same. Like we had the example of, what was it? Shoot. Oh wait, no, those were book titles. Okay, but authors could have the same name. So we kind of want to make an author ID by ourselves and call that the primary key. And track the author name as well as the genre that they write in. Okay, and then each book's title and publisher is recorded. So this is where we also need a book ID, primary key. So title and publisher. Okay, so now we've got our entities set. So our entities are done unless we have a many-to-many relationship, and then we need to reevaluate. So before we move on, now we need to assess what the relationships are and their cardinality. So we need to reread. So when patrons come to the library, they check out at least one book. So let me jot down here. So we've got patron to book. So when patrons come to the library, they check out at least one book. So for each patron, we've got, actually, let me put this right here. Okay, we've got many books per patron. And then, one second, okay. Addition to book and patron information, right, so many, all right, then it kind of, it digresses, so it moves to, so we'll have to come back to that. Many textbooks are written by multiple authors, so we've got book author. Oh yeah, okay. Okay, so for foreign keys, so if you have a one-to-many relationship, the primary key of the one side, and I'm typing it in the chat, becomes the foreign key for the many side. So I think we'll have an example here. Yeah, so the primary key on the one side becomes the foreign key for the many side. And then in a one-to-one case, one-to-one, the side that, well, you have to think about it as what's scarier, A without B or B without A. And if it's scarier for one side not to have the other side, like in the case of, oh, I'm looking at the quiz. In the case of the plane and pilot, so the plane has to have a pilot. So if we have the relationship, so plane to pilot, the plane has to have a pilot. So the pilot ID becomes the foreign key on the plane side of the relationship. So the pilot ID primary key becomes foreign key on the plane side. So it's, if that side requires it, then it receives the primary key from the other one. I'm not going to type that out because I'm not sure that will look like. Okay, and then many-to-many, we'll see I think we'll see an example of that very shortly. Basically, both primary keys become primary key for the intersection. Okay. All right, so we were talking about book author. So many textbooks are written by multiple authors, and the library carries books by prolific authors. So we've actually got both sides of the relationship right there. So many textbooks are written by multiple authors. So for each book, we can have multiple authors. And the library carries books by prolific authors. So for example, so for each author, we can have many books. Okay. And so we do have a many-to-many relationship here. But let's keep reading. A library book, so I'm reading back up here, can only be checked out by one patron at a time. So that's going back to our first relationship between patron and book. So each book can only be checked out by one patron at a time, so we have a one-to-many relationship. And in fact, now we're up to the attributes again. It looks like those are our two relationships that we have. So now we define them in the ERD. So let's see. So let's start with the one-to-many because that's the easier one to negotiate. So patron to book, so I'm just going to draw a line here, and don't forget to include the relationship diamond, okay? So that's how we're going to want to see it. Where is that diamond? No, you can't help me because you're not here. Let's just pick this one out. Okay. So, and we need a word that kind of describes, so we'll just say checks out. Seems to make some sense. Okay, so we've got the diamond, and then yeah, so we have a one-to-many. So one patron can check out many books. So we need to represent that. I'm going to draw some crow's feet on the book side of the relationship. So now we see for every book, we've got one patron, and for every patron, we can have many books. All right, now addressing our other relationship, so patron to author. So we do have a many-to-many case here, so also let's not forget our relationship diamond. So patron author, oh, I'm sorry, I drew this in the wrong spot, and I'm sure you guys recognize that already. Patron author, that would be super weird. Again, it's because I'm just talking to myself here. Obviously that's not right, so book and author. Okay. Yeah, so book. Yes, a book can have many authors, and an author can write many books. Sorry about that. So let's just say writes. Okay. All right. And we do have many-to-many here. So what I'm gonna do is actually drag this down so we can have it a little bit more cleanly here. Okay. So first what I need to do is represent the many-to-many. So I've got crow's feet on both sides of the relationship. Okay. And now we have many-to-many, so we need our intersection relationship. So what we're going to do is make a completely new entity, and we're going to call it by both entities' names. So I'll just call it author book. You can also call it book author, it doesn't matter, as long as both are represented. And we will connect this to the relationship, so not any of the entities, will connect this to the relationship, and then our primary key becomes what we called a composite key of both primary keys from the contributing entities. So author ID and book ID. Now, just as a reminder, if you are representing an intersection in the table schema notation, both of these will both be primary and foreign keys. But in the case of the entity relationship diagram, we just need to represent the primary key. We don't need the foreign key. Okay. Now let me know if you have questions about that. But now we've got entities, check, got all the primary keys, check. We figured out what the relationships were, check, and then we had a many-to-many case, so we needed to create an intersection. All right. So that's the testing center portion in a nutshell. I'll take questions on that, and let me look back at what people were saying. So how do you suggest studying for the exam? I mean, this study session should give you a good idea of what to expect. If you're looking for more, I would suggest going back through the study guide sheets that are posted on most of the days of class. Those will have the key terms and things like that on them. And then you can practice ERD again, maybe go over your old quiz. And then for the practical side, essentially your 2 projects and the homework are the basis for that. So if you can go over those, and then I think there's additional practice, and I'll do some examples here, as well as the only other thing is the SQL examples, the practice problems, which will help you both on the practical side and the testing center portion, because you'll have questions where you need to decide, you know, what is the appropriate query to make when you're addressing a specific question. Okay, and then what is latency concerning memory? So the point I was trying to make there was that the closer it is to the CPU, typically the faster it's going to be. So latency, that just means how long it takes for data retrieval. So on your external devices, secondary storage devices, it's going to be a lot slower than the cache, for example, which is stored on the CPU directly. So. Okay. Again, there's some latency here actually between what I'm doing and you're listening and then you're emailing. So let me know if you have other questions. What I'm gonna do now is switch gears. So talk about the in-class portion that you're gonna do tomorrow. Now, not to freak you out, but the in-class portion, it's designed to test your time management skills, as well as your skills in terms of actually, you know, performing the queries, doing the solver, and creating the pivot tables. So you will need to budget your time wisely. I would suggest hitting those access queries as soon as you can, because they make up the bulk of the score, essentially. So less time, if you can, on the solver in Excel. Definitely hit up those access queries first, or you'll probably regret it. So that's my advice. Okay. So speaking of which, I will just go through a few of the practice problems that I posted on Learning Suite. So these were not things that we did in class, nor were they part of your homework. These were things that I just created on the side. So if you're looking for them, I think they're in purple or something. Back in week 3, that was a while ago. Under Thursday, January 22nd, you've got the practice problems and the key. So essentially the text for the problems is in here, and then you've got the text. So the text solution will have the SQL formatted as you might see it on the exam, and then this is sort of during the in-class portion, you'll download a database and need to create query tabs in it in Access, and so the solution for that is right here. Okay. So I'm going to pull up the Practice Problems. There. All right, now the purpose of showing you this relationship and collection of the different entities involved is for the testing center portion. So essentially, you're going to have to work from this schema that you might see in Access and decide what are the proper SQL queries that you would need in order to answer the questions. But in the, where's my database? So in the database, which I downloaded, so all I did was I took the gold star data that we had and I added a new entity. So I added security system because I wanted to show you how to jump around the tables, just in case we didn't get to that well enough in class. Okay, so let me pull these up side by side. So, first question. So what is the SQL required to return the first name, hire date, and salary for all employees with the last name of Jones? Okay, so if we look at the table schema here, and we think, okay, we need first name, hire date, and salary for all employees with the last name of Jones. And I know I'm being pedantic about this, but I think it will help you in the long run. You recognize that all of these things are coming directly from the employee table. So we don't need to do any fancy connections, linking foreign keys or anything like that. We just need to pull from the one table. The only special thing that we have to do is make sure we have, in our where clause, which is usually our criteria, the last name of Jones. So let me do the SQL first, and then I will do it in Access, because I think that makes more sense. Okay. All right. So in fact, let me just pull this back up because I don't need Access. Okay. So I look, and it's very important to understand what is being shown here, because that tells you what you have access to. Okay. So we always start with select. So select the things that we want to display. And again, you won't have to write SQL, but you will have to be able to discern between different SQL queries the way they're written. So I think it's helpful to understand how to write it. Okay, so select, so first name, and in Access you do not have to use it. So I'm actually just gonna write this as though there's no space here. Okay, so first name, hire date, salary, from. So select from, we've got our employee table, and it's important to review the order of those clauses that we use. So whichever tables that I'm pulling from, that's what I need in the from clause. From employee, and then we do have a condition here. So if I had no condition, I'd be done, minus a semicolon. I would just be selecting first name, hire date, salary from employee. I would get all of the first names, hire dates, and salaries for all the employees from that table. But I do have a where clause. I need to know with the last name of Jones. So where last name equals Jones, in quotes like that. Okay. So let me pull this up. So in Access, what we're going to do, we go to create, and I'm sorry I'm using 2010, but I think it's exactly the same. I have 2013 on my work laptop, but I have 2010 on my home computer, so. Alright, so query design, and then decide what tables we need. We only need the employee table, so I am going to add that. Close this, and then I need first name, hire date, and salary, and it's coming from employee, and then where last name equals Jones. So what I'm going to do is I'm going to add last name, but I don't need to show last name. So, and this is important when you're, actually doing the queries. But again, you'll have a quiz that goes along with it, and so there's going to be, you will get a paper version of the queries that you need to do. So you're not going to have to manipulate different things at the same time. I think it's just easier, and you'll do the queries and then you'll answer the quiz questions. So you'll need to, again, it will exactly the same as your project, upload the file, as well as answer the quiz questions. Okay, so I'm not going to show last name, but I will have the criteria that last name equals Jones, so I'm just going to put Jones in quotes here. I'm going to save it, and then if I run that, yeah, I get, so assuming that Holly's last name is Jones, first name, hire date, and salary. Okay. So, with last name Jones. So the question just came in, do you need semicolons between commands in SQL? So no. So well, you need a semicolon after every big long thing that's attached to select statement is done. So essentially you can think of the entire, it's when a query is finished. So this is the entire query. So then I end it with a semicolon. Each of these statements is still part of the query, so I'm not going to end it there. That will make the compiler very confused. So just at the end of each SQL query is when you need the semicolon. Okay, all right. Whoops. Okay, second question. So, and actually what we can do is, I'm in the, what is this? Table view. I can go to the SQL view on this query, and so Access insists that you have the table name every single time, which is kind of annoying for our learning purposes, but essentially you can see it has select first name, hire date, salary, from employee where last name equals Jones, semicolon. And so the SQL happens to match exactly what we just did, which is good, and we got the data that we wanted. Okay, so I'm going to close this one. Sure. All right, so next one, and I apologize, I guess I'm just taking more time than I thought I would, but it's actually probably a good thing for you, so. All right, what is the SQL required to return the hire date? I'm going to pull this up again. Make it bigger. Okay, so we're done with this one. To return the hire date for all employees with the letters ON anywhere in their last name. Okay, so I'm going to, so we always start with select. So what do I need? I need the hire date. And again, if I make a mistake, just let me know. I can make mistakes. So select hire date. So from, again, we just have the employee table. And again, we can cross-check with the table diagram just to make sure. This isn't important now, but it will be in some of the other queries. So I just keep referring you back to it. Okay, so from employee and then where, so we have our condition. So with the letters ON anywhere in their last name. So we've got where last name, and then our keyword like, ON. So ON has to be anywhere in their last name. So essentially we're going to need a wildcard. So anywhere, so I've got as many different letters as I can have, and then ON, and then more letters, bunch of letters, end quote, semicolon. Okay. All right, so if we, make sure I can see everything here. We move to access. We answer the same question, so create query design. So I want, sorry, it's moving. Hire date. So I only need the employee table is what we said. So I want hire date for all employees with letters ON anywhere in their last name. So I need the last name, but again, I'm not going to include it. And I need the criteria that we have wildcard, ON, wildcard, end quote. Okay, let's save that and run it. And this should be the hire date. If I showed the last name, it should just be the employees that have ON in their last name. If we look at the SQL, yeah, we've got, so select, again, it's including the table names, but hire date from employee, where last name like star on star, end quote. Okay. All right. You can stop me if you want. I'm just going to keep going. All right, so next query. So they do get progressively more difficult. What is the SQL required to return the first name, last name, and performance of all employees whose minimum salary is greater than or equal to 25,000, sorted by hire date in descending order? Okay, so we've got a lot of different things going on here. So let's start with just the things that we want to display. So select, that's easy, right? So select first name, last name, performance. And so the key here, so I was saying, you know, you need to reference the correct tables. So if we take a look, so first name, last name, performance, if I scroll up, I see first name, last name in the employee table, but I see, oh wait, no, performance is here too. Sorry, I'm jumping the gun. Oh, okay. Sorry, it's been a while since I've looked at these. Okay. Bear with me here. So select first name, last name, performance. We obviously know, so from employee, but then we need to read the rest of the query. So whose minimum salary is greater than or equal to 25,000. So if we look at the table, so minimum salary is stored where? Minimum salary is stored in the position table. So we actually also need the position table. So it's important to read the entire query before you make decisions about what's included. So employee and position. And then we've got our criteria, so minimum salary, so where minimum salary is greater than or equal to 25,000. Now we also need, I'm skipping a line for a reason, I'll explain in 1 second. Actually, you know what? I'll explain now, because this is, I think, something that a lot of people had questions about. Okay, so essentially what I've done, I had first name, last name, performance, and I needed to pull the minimum salary data from the position table. So because I did this, I need to let the processor, the compiler, know how to get to that information, because it's not in the employee table. Okay, so it's in the position table. I need to know how to tell it to get from the employee to the position table. And I can answer questions about this again, because we'll do, the next few examples have this as well. So because minimum salary is not in the employee table, it's in the position table. So I take a look, and sure enough, I need to bounce from the employee table to the position table. And now in order to do this, what I'm going to do is include a condition that sets the foreign key equal to the primary key of the related table. So I'm going to set position ID from the employee table equal to the position ID of the position table, like so. So, and, because I have multiple criteria, so this time I need the table name. So employee.position ID is equal to position.position ID. Okay. So the idea here was that we had things from both tables, so we needed to tell it how to get from one to the other. And in order to do that, we make a link on the foreign key that's the primary key in the other table. We need to set those equal. Okay, we're going to see another example of this. So sorted by hire date in descending order, so we just have the one last criteria. So we simply order by hire date, and then ascending is the default, so we need to put descending in there. Okay. So we've got our SQL. Let's take a look at how we would do this in Access. Create query design. Okay, so I was just saying I need the employee and the position table. And if you notice, what Access is going to do, and I think some people struggled with this, so I want to say it again. Very often, if your query isn't working, it's because you are asking for data that it can't get to because it doesn't have the link. So if, you know, we're trying to get to, say, another table that was connected to employee but not to position, you'd have to include employee in order to bounce over both links. Okay, so I needed first name, so that comes from the employee table, last name, and performance. So all the things we're displaying come from the employee table. But my criteria, minimum salary is greater than 25,000, comes from the position table. So I'm not going to show that, but so is, I all of a sudden forgot how to do this. So is greater than or equal to 25,000. I don't know why that looks wrong to me. But, and then we need to order by. So we, what was that again? My mind's actually drawing a blank. I actually know how to do the SQL better than work in Access here. So where's the order by? We've got totals for our aggregate, and then builder for our formula. TA, if you want to jump in, that would be fine as well. Oh, sort. Again, it's because I'm talking to myself. That's so silly. All right, descending. So simple. Okay, save. Hit OK, and then we'll run it. And so sorted by. So we've got first name, last name, performance. And you can double check the key. This should be correct though. So whose minimum salary is greater than or equal to 25,000, sorted by hire date in descending order. So just to double check, what we can do is, oh, I sorted on minimum salary. Okay. These are the things that you need to make sure you've got correct. So sorted on hire date, I apologize, in descending order. Let's run that. There we go. But I don't want to show hire date. Go back. I'm going to show everything so we can make sure that we've got the query running correctly. Okay. Yeah. So now we've got everything satisfied. So minimum salary is greater than or equal to 25,000, and hire date is sorted. It's sorted on hire date in descending order. So it's getting further and further into the past. But in the design view, we don't want to show any of these. So that is our resultant query. Again, stop me if you have questions about that. You probably caught the mistakes I was making as I was going, which is good. So, all right. Okay, a little fancier here. Let me close this query. Okay, what is the SQL required to return the first name, last name, and position title of all employees who are protected by the super safe security system? So if we look, so super safe security system, you think, well, what's that all about? If I scroll up, I can see in the security system entity or end table that I've got a system ID, a system name, and a contact number. So we're going to assume here that super safe is an example or an instance of the system name. So scroll back down. So I want, so select first name, last name, position title. Let me scroll up to make sure that that's actually, yeah, position title. So of all employees who are protected by the super safe security system. Okay, so this is a case where I'm going to have to bounce through multiple tables in order to get this. So from, let's skip the from clause for just 1 second. What do we know? We want to get things that are protected by supersafe. So where, so the system name, but I'm going to need to tell it what the table name is. So the table name is, if we scroll up, so security system. So security system dot system name is equal to super safe. Okay. All right. Now, so I'm looking for first name, last name. So first name, last name, those things come from the employee table. So I already know that because I need the system name, I need to bounce from the security system table to the location table to the employee table, because there's no direct connection between the two. So I can't just set a foreign key to a primary key in the employee table. I need to set system ID equals system ID, then location ID equals location ID. I have to make both connections. But additionally, I also need the position title, which is in the position table. So because I need to get to the position table, I also need to set the position ID in the employee table to the position ID in the position table. Okay, so does that make sense? I'm getting all the way from system name all the way over to position title and having to set each foreign key to primary key as I go. So let us do that. So it's going to be a lot of clauses. So this is where you just want to make sure that you've got all the clauses if you're looking at a problem. Okay, so so I just described, I need all those tables, right? So I need from, so employee, location, position, and security system. Okay, so I need all those things. And then I also need, so what I'm going to need is a bunch of AND clauses that just make those connections. So I'm trying to simplify the process in your head for you so you don't get confused about what you need. If you need to get from one table to another, you need to include a clause that connects foreign and primary key. So how do we do this? So first, so I can do where security system dot system ID equals location dot system ID. Security system dot system ID equals location dot system ID. Oops. And so I just got from the security system table to the location table. Then I need location.location ID equals employee.location ID, so to move one other table. So location.location ID equals employee.location ID. And finally, I need to get from the employee to the position table, so position ID equals position ID. So employee.position ID equals, position ID. Okay, and that, ladies and gentlemen, should be, yeah, so that's everything that we need there. So it's a pain, but we have to connect all the tables so that we know what's going on. Okay, so to make the query, so if I look, so this is going to be a case where maybe something wouldn't work if you didn't include everything. So first name, last name, so that's coming from employee, and then position title, so I've got position right there. But then I'm thinking, okay, I need super safe, let me pull up the security system table, and I see that it's not connected. So how do I get it connected? I need to add the location table. I don't need to add an extra position table. I need to add the location table, and now I can see all of the connections here. So I think some of you struggle with this a little bit on the homework, or sorry, the project. So the connections have to be there. All right, so first name, last name, and position title. So I'm pulling from here. And then I need system name, and that's going to be equal to super safe. I uncheck it, and I believe that's all I need. So I save, run, and so those are all the people that are protected by that system. And we think it makes sense if you think about it, because the system is connected to, if we look at the diagram, the system's actually connected to a location. Each location has only, so a security system can be used at multiple locations. Each location only has one type of security system. All right. So just because I don't want to spend too much more time on that, but I can, if you ask me to come back, I would like to move to, because those are kind of the main issues. You need to know how to get from table to table. You can try the other two on your own. You need to know how to get from table to table. So in Access, we can do some more access examples if you would like, but one of the main things is that you need to make sure that you have all the connections that you need in order to display the correct data. Okay. All right, so if you have questions about that, let me know. I'll start moving to solver and then do some pivot tables. So solver, I'm just going to glance over if you have questions. Yeah, so access queries, let me just say a few more words about that. Yeah, it's really key, again, to read the problem. So I think a lot of people struggled with it, getting exactly what was going on in the system on the project. I don't want to say anything in particular about the project because I don't want to record talking about it in case we, use it again, but you have to think about what's being stored and if it makes sense to have certain data without having other data, if that makes sense. So take your time reading the questions, but yeah, focus your attention on the access queries because they're the bulk of your score. Okay. All right, so in terms of solver, I just wanted to do one example paired with just a brief review of the linear programming aspect, just to remind some of you how to do the calculations on solver that you might need to do. So we'll look at the donut example again. Essentially, so we have donut shop. I know we went over this in class, but so it sells 3 different types of donuts. I crossed out this information because it's really not important to us in solving the problem, and that's also something to keep in mind when you're solving the problems. And then it tells you how much each one is sold for. It then gives you how much you expect to sell, so you kind of in your mind think, well, those are our demand constraints, and then how much labor is required for each type. So in solver, let me bring that up. Essentially what's asked for is what your objective function is, what needs to change in order to maximize or minimize the objective function, and then what constraints that you need. So I think some people were struggling with, so for example, on your homework, you had to set the objective function in the spreadsheet, because when you pulled up solver, some of you tried to solve it and it came back to you with an error. It said, I need a formula or something in that cell. That's because it doesn't know what it's maximizing. So if you think about it in terms of linear programming, what are we maximizing? We're maximizing profit. And so we're maximizing profit, so how do we characterize profit? Well, how much do we sell each type of donut for? It tells us, and so we just need to decide how much we sell each individual donut for, and then add those things together. So, for example, if I set, and again on your spreadsheet, you'll have cells that represent the number of things made, maybe the number of things sold, the number of inventory that you have. So these are going to be your decision variables, the things that change. So profit in our case is going to be the number of donut holes times the profit, so 0.05 times H plus the number of regular donuts times its profit, so 0.3 times R, plus the profit of the special donuts times the number of special donuts. And I kept asking people who came in to see me, if we had no constraints, how would we maximize profit? Well, we'd sell as many of each type as we could, because we don't have any constraints, and the profit would essentially go to infinity. But that's not practical, so we have constraints. So we read the problem to determine what the constraints are. But let me stop here for a second and switch back over to solver. Put this over here. So solver wants to know what the objective function is. So we need to tell it in a cell. So profit, and I keep saying function, so profit is a function of how many of each type are made. So if you change, the number of each type made, the profit's going to go up or down based on what those numbers are. So as well as based on the profit. But the thing that changes is how many are made. So what I'm going to do is I'm going to take the sum product Sometimes it'll be a sum product, sometimes it'll just be a sum. You have to understand what's being stored in the sheet. So the number made and the profit for each one. Okay, and I can stylize it as currency. So I can see 1680. All right. Now the constraints, oops. So the constraints, the Excel file tells me what the minimum and maximum demand are. Very often demand will be one of your constraints. And you'll have to say whether or not you're going to equal to meet the demand or just be underneath the demand. But you can't make more than the materials that you have available. So things like that. You can't get rid of more inventory than you had to begin with. So these could also be constraints. All right, but sometimes a constraint will be a function in itself. So in this case, we have this. We have the total labor that gets used is a function of the number of donuts of each type that's made. So very similar to how we wrote out profit as a function, we can write out labor as a function. So as the sum product of how many are made and the amount of labor that it takes to make each one. So essentially all it's doing is it's taking a look at how many are made and plugging that number in, so telling you what the total labor is based off how many are made times the amount of labor it took to make them. Okay, labor available. So sometimes I actually think it's going to be set for you, but so that just to point out the difference between the labor available and the total labor used. Labor available, this is just a constant number that we have in the problem. So you only have 20 hours of labor available. So that's why we have this here. But we have our labor used as a function. Okay, so let's just review how to do this in Solver. So we go to Data tab and go to Solver. And then set objective. So I like to say objective function, so that we already filled in the profit cell on the data sheet, so we can go ahead and just click on that cell. We want to maximize it. A few people miss this, but make sure you've got, I explained simplex. I showed the gentleman with the comb over. He wasn't the inventor of simplex, but George Danzig. So he wants us to use simplex LP, so LP standing for linear programming. So which cells do we want to set for us? So how many are made? So just highlight how many are made. And then subject to constraints. So we talked about demand and we talked about labor. So first let's do the demand. So I can highlight multiple things at the same time. So I want the number made to be less than the maximum demand. And I also want the number made to be greater than or equal to the minimum demand. Okay, and then I want the total labor used, can't use more labor than I have, to be less than or equal to the total labor available. Okay, and you have to think about, so is the thing that you're dealing with, is that something that needs to be an integer? If it is, then we also need to add the integer constraint. So the number that we're making has got to be an integer. So I think a few people might have missed this on their Solver project. It's better to be safe than sorry, but if it's something like, I don't know, something that's not countable in that sense, like gallons of gas or something, then you're not going to want an integer. But in the case of, like donuts or jewelry, burritos, things like that, you're not going to sell half a burrito. You need to make sure it's an integer. So it's solve, and Solver has the results for me. Now, when you are doing this, you're going to just a few little items. Make sure you hit OK, instead of cancel. And if at any time you're having trouble during the exam with a little computer issue, just call me or the TA over and we can take a look at what's going on. But please remember to save it in that sense, so that because if you hit cancel, the numbers are going to disappear. And so I know you're under a time crunch, so I'm saying it now so that you'll remember to do that. Okay, so I just kind of want to do that one example to make sure you remember to set the functions that you need if you need functions. and then to make sure you're using simplex LP, you have the correct, so it's, you know, max profit, min cost. That's how we do things in the business world. If you have questions about that, let me know. Send an email to the TA, and I will move briefly. We'll just do a few pivot table examples, and I think that will be everything but the kitchen sink. So, all right, so what I'm going to do here is I am going to, and so in terms of the pivot table stuff, I mean, I purposely made the project due tomorrow so that you'd be working on that as well. And so that, you know, your reviewing would be taking place as you were working your way up to it. So I can't answer questions about the project here, but I can do some examples or answer specific questions about you know, how to manipulate pivot tables if you would like. So what I'm going to do, I'm going to use off of Learning Suite. There's, if you go to the pivot tables and charts, so week 5, that Tuesday, downloading the Western Regional Dataset and the practice problems. Okay, so I'm going to pull Excel over. Well, it's a little bit tricky to manage both of them at the same time. I'll just make this a little bit smaller. Okay. All right. So I have some questions here. You can pull it up on your own computer. So again, it's important to study the data set first a little bit so you understand what you're dealing with. So for example, it looks like we've got a shop here, different sale dates, different items that were sold, different locations, different sales reps and sale approach. And stop me, I don't think was this the one we did in class? Let me know if it is. I think some of the questions are a little bit different, but even if it is, it wouldn't hurt just to go over a few of them again. Okay. So first question, so how much bicycle revenue did the Provo store receive in the month of October? So again, what you're going to want to do is for each question, and I believe the setup is you will download the Excel file, and it will already be divided up into tabs for you. So essentially on each tab, you'll have the opportunity to create the pivot table that you need. So don't worry about making new tabs, and the questions should be on there. So you won't have a separate sheet for that. You'll just download the file and then work off of it. Okay, so insert. So I highlighted. I'm actually going to do highlight the top and then hit Control-Shift down. The hardest queries. So someone's asking about, you know, the hardest. Oh wait, okay. Yeah, the hardest queries, pivot tables, and solver problems that we should expect. So the hardest queries, it's hard to say what's hardest, right? Because sometimes it's just something that you miss. Hardest, I guess I would say two things. So first, sort of the last couple questions in the SQL practice that I was doing. So hardest will be you need to jump around tables. That's going to be one of the components. / you may also, well no, I mean it's the same as it was on the project. The hardest ones for people were the ones where they needed to make connections or they missed something based on the question reading. So it's hard to kind of quantify what those are exactly, but if you think of it that way, that's going to be the hardest queries. Solver problems. So solver problems, in terms of it being hard, I would just say you need to make sure that you have, if you have a function in solver, that you are characterizing it in the proper way. That's going to be, you know, the hard thing. Or for example, we did some cases where So just let me do a few reminders about Solver. So again, about Solver, make sure you're highlighting the correct cells that you want changed. So in this problem, I actually made a mistake in one of the sections, I think it was the 8 o'clock. Rather than highlighting these cells that were going to be changed, I highlighted cells with a function in them already. And that was a big mistake because I was telling Solver that I wanted to reset these cells to be certain values. When in fact, it was these cells that were going to change. These were just already aggregate functions of the number to be shipped. And then, you might run into, we did an example with, so we had technicians that couldn't make certain types of transistors, and we just needed to make sure in the solver that we included those as constraints. So we had to set the number of units made for a particular technician to be 0, like for example here, if they couldn't make that type. So those things like that might catch you. But yeah, the hard in terms of solver will just be making sure you have the right functions set up. And in terms of the pivot tables, for me, pivot tables are actually the easiest of the thing because it's the type of thing where you can visually see the answer. You have the question in front of you, it's asking you what percentage of what, or the difference of, or whatever it is. If you have the answer in front of you visually, then you've got the right pivot table. It's as simple as that. So hardest things in terms of pivot tables, that would be those percentage of, for example. So we can skip down and do one of those, but essentially you need to know whether you need to go row or column on that. And sometimes it's a matter of reading the question and making sure if you see something like, where is it? Like all 3 months and all 3 stores. This might trigger in your head, oh, I need to show all 3 months and show all 3 stores, but you really don't, because if you want the total from all 3 stores, all you need to show is, you don't even need to show store, you just need to show the total for it. So yeah, let's actually skip down and do that one. So number 3, so I was just, I highlighted the table, so insert, pivot table, there we go. Okay, and again, you won't have to, so I'm just going to leave it as sheet 1 because you will not have to make your own tabs. It'll just be in the document. So question 3, so what was the total revenue received from pajamas comprising all 3 months in all 3 stores? So you have to decide which values you want to show. So that's always key. So I want to show revenue, so I need amount. And then I want to double check, do I want the sum or do I want the count? Or do I want the average? Those should be the main 3. If I want the count or the average, I need to change the value field setting. So am I wanting the number of items? The average revenue? No, in this case I just want the sum. So I'm gonna make it currency. So I want the total revenue received from pajamas. Okay, so pajamas, that sounds like an item to me. So I'm gonna drag item down into the row labels and take a look at which items I have. Now, so all 3 months in all 3 stores. So the word all there triggers in my head, well, I'm just about done here. I've got all 3 months, all 3 stores all together, because this is just aggregate. So I just need for pajamas, so I can do one of 2 things. I can click on the drop down and select only pajamas, or I can simply highlight the cell that has the answer that I'm looking for. Okay, and so, if there's a question like that, you just need to make sure you're highlighting the correct cell or only showing what needs to be displayed. Okay, so let me see if I can find a little bit tougher one. Okay, so let's do number 6, because it's got percentage. Alright, so I'm going to go back to sales data. It's already actually highlighted for me, which is nice, so I'm just going to click Insert Pivot Table, hit OK. So number 6, so what percentage of, I can probably make it a little bigger too. Okay, maybe not, let me get rid of this thing. Oh no. That's what's going on. Okay. What percentage of total revenue of all stores combined for all months did all the stores achieve in October? Okay, so sounds like, alright, so it's mentioning a specific month, so that makes me want to kind of divide it up by months. But then it's mentioning all stores. So total revenue, all stores combined for all months. Did all the stores achieve in October? So I probably don't need to divide it up by stores at this point. So I need the amount. Okay, because that's going to be my total revenue. So let's make that currency. And then, okay, so I'm going to need the date for October. And again, so if you pull in a date, you're going to want to right-click on one of those dates and go to Group, and then usually month is what we want, but if it's months, maybe you want year. But in this case, we want months, and that makes it nice and compact. So what percentage of total revenue of all stores for all months did all the stores achieve in October? Okay, so what do I want here? I want the percentage of the total revenue basically that was achieved in October. So what was the total revenue? Well, it was all three from September, October, and November added together. It's 10,402. So the percentage, in order to get the percentage of just October, I would just simply, if I were doing a calculation in Excel, divide 3,169 by 10,402. But what I really want to do in terms of the pivot table is go to value field settings for my value, and go to show values as, and then here's where I was saying you need to know whether you're going row or column. And it will make sense because if you think about what ends up in the total, whether or not it's 100%, you can kind of think about whether or not that makes sense. So I want the column, in this case, percent of column total, because the column total is the grand total for everything. So hit OK, and yeah, so this makes sense because the grand total divided by the grand total will be 100%. So for October, that's going to be 30.47%, and it already formats it for you. So I can just highlight that, and that will be my solution. Okay. All right. So at this time, I'm going to stop, and if you have more questions, let me know. And I'll just wait for a minute or two to see if they come in. I didn't realize I was going to go this long, but I appreciate your willingness to participate. So, and I'm happy to be able to provide this for you as well. If you're wondering what my desktop is, that is Mikasa Ackerman from an anime, which is a little embarrassing, but you know, I'm not actually into anime that much. It's just it happens to have a really good storyline. So anyway. So now's your chance. So speak now, forever hold your peace. Essentially, once we get in there, we're booking it. You know, so get there on time tomorrow, because you'll have 75 minutes, especially for those of you in the 8 o'clock. I can't stress that enough. If you're in the 8 o'clock section, please be in your seat at 8 o'clock so we can get started as soon as possible. And, okay, great. If you are wanting to take it in the lab, I'm not accepting any more. So if you emailed me before I'm saying this, you can take it in the lab. But anything after this point, we've got enough. I think we're at capacity. So, but if you are taking it in the lab, just meet in the classroom, and then the TA will walk you over. We're actually going to do it in 204 instead of 240 because there's a class in there. But you'll have just access to computers as though you were in the TA hours. Okay, well, if that's everything, thank you very much. And we'll see you, some of you bright and early tomorrow, some of you less bright and early. But good luck. And actually, if you're still listening, let me know if you would like to say a prayer before the exam starts. So I will need one person for each section. I think I already have one for one of the sections. So if you email me about that section, we can just do it for the next exam. But let me know, and I will see you tomorrow. Good night.